What if I told you that the future of AI, the real key to building a true thinking machine, isn't some brand new thing? What if it's actually hiding in a forgotten invention from over 60 years ago? Well, today we're going to talk about exactly that. We're diving into the incredible story of a self-taught genius who basically laid the groundwork for a cognitive computer, a machine that learns and processes information just like a human brain.
Okay, so let's just start with a question that gets right to the heart of the problem we're facing. Think about this. Your brain right now is performing absolute miracles of computation on less power than it takes to light a dim light bulb. Meanwhile, the data centers that train our most advanced AIs are consuming the energy of a small country. So, what's the deal? Why the huge difference? It all comes down to one thing: architecture.
So here's the thing. Almost every computer you've ever used is based on something called the von Neumann architecture, and it has one single critical flaw. The processor, the part that does the thinking, and the memory, the part that stores the information, are in two different places. So the computer is constantly shuttling data back and forth, back and forth. It creates this massive traffic jam that we call the von Neumann bottleneck. And this constant shuffling isn't just slow, it's what burns up all that energy. Your brain, on the other hand, it's a masterpiece. Memory and processing happen in the exact same place. Information isn't just stored somewhere, it's literally woven into the structure of 100 billion neurons. That is the model for a truly efficient cognitive computer.
So, who was the person who first really tried to tackle this problem? You'd probably guess some professor at a big university, right? Well, the story actually starts in a much more unlikely place. I want you to meet Stanford Ovchinsky, a totally self-taught inventor and a prolific one at that, with over 400 patents to his name. This was a guy who saw connections that nobody else did, driven not by degrees or credentials, but just by this relentless curiosity about how the world and, how the mind actually works.
I mean, his journey is incredible. He starts out in the 1940s as a machinist, and right away he invents this revolutionary high-speed lathe. But his mind was already thinking bigger. He got obsessed with this new field called cybernetics, which was all about how animals and machines control themselves. And get this, by 1955, this machinist from Akron, Ohio, is writing scientific papers about the fundamental nature of a nerve impulse.
And that fascination led him to his big idea. He realized that neurons, they aren't simple on-off switches. They're not just ones and zeros like in a computer. No, they're analog. They're cumulative. They gather all these incoming signals, sort of adding them up until they hit a certain threshold, and only then, bam, they fire. This single idea, that switching isn't just on-off, but that it's cumulative, that became the foundation for everything he did next.
Okay, so he's got this amazing concept of a threshold switch. Now what? Well, he had to build it. He needed to find some kind of material that could act less like a light switch and more like one of our own biological neurons.
And he found his answer where literally no one else was looking, in amorphous materials. Just think of glass. Unlike a perfect crystal where all the atoms are in neat rows, in glass they're all jumbled up and disordered. At the time, the entire solid-state physics community was obsessed with perfect crystals for making transistors. They thought these messy, disordered materials were totally useless for electronics. But Ovchinsky, he saw something different. And then, the moment, his eureka moment. He's applying voltage to this thin film of a special type of amorphous material, and he sees this distinct cross pattern just bloom to life on his oscilloscope. He knew, instantly, he'd found something totally new, something that just defied all the physics of the time.
Okay, so let's break down what he actually saw. This is what's now called the Ovchinsky effect. You start with this glassy material that barely conducts electricity. You apply a voltage, you turn it up, nothing really happens until you hit a very specific threshold. And at that exact point, bam, the atomic structure of the material literally snaps from that messy, glassy state into a neat, ordered, crystalline state, and it suddenly becomes superconductive. It was a physical switch that behaved exactly like the neural threshold he had been dreaming about for years.
And here's the crucial part. Because this change was reversible, you could use an electrical pulse to flip the material back and forth between its two states, amorphous and crystalline, high resistance and low resistance. You could store information not just as a 1 or a 0, but in the actual physical structure of the material itself. This was the birth of what we now call phase change memory.
You gotta understand, for Ovchinsky, this was never just some happy accident. This was the whole point. He wasn't just trying to build a better memory chip. He was trying to build an artificial neuron. He wanted to create a physical solid-state synapse, and with this discovery, he finally had the building blocks to do it.
But you know how these stories go. When you have a guy with a high school education claiming he's just overturned the entire foundation of solid-state physics, well, you can probably expect a little bit of pushback. And that's exactly what he got.
So mark this date, November 11th, 1968. Ovchinsky finally announces his discovery to the world. It should have been this amazing moment of triumph, right? Instead, it ignited a firestorm of controversy that would literally follow him for decades.
The reaction was just completely split down the middle. On one hand, the press saw a revolution coming. I mean, it was front-page news in the New York Times. But the scientific establishment, they were furious. Who was this guy? No PhD, no university backing him up. He was an outsider, a machinist, and his claims seemed to violate everything they thought they knew about how semiconductors worked. They basically dismissed him as a fraud.
So what came next was this long, slow journey. For years, Ovchinsky and his company, ECD, they actually developed a lot of related tech you've probably used, like rewritable CDs and DVDs. But when it came to his big dream, core computer memory, his phase-change tech just couldn't compete with the massive industry behind cheaper flash memory. For decades, it looked like his grand vision of a cognitive computer was just going to be a footnote. Until 2015.
So in 2015, Intel and Micron make this huge announcement about a revolutionary new memory technology called 3D XPoint. They're touting it as the first new memory category in decades. And what was the magic behind it? You guessed it, a chalcogenide material and an Ovonic switch. It was Ovchinsky's technology, almost exactly as his team had designed it way back in 1989. After all those decades of being dismissed, his work was finally, if kind of quietly, vindicated.
But you see, faster, more efficient memory was never the endgame for him. This vindication just brings us right back to his ultimate ambition, the cognitive computer, a machine that doesn't just store data, but processes it, learns from it, and thinks with it, all in the exact same place.
And this is where it all comes together, connecting right back to his original idea about the brain. Ovchinsky's team figured out they could trigger the material not with one big binary pulse, but with a whole series of smaller, cumulative ones. The device could actually accumulate these little inputs of energy until it hit a threshold and fired, just like his 1955 model of a neuron. This is a total paradigm shift. It means you can do the computation inside the memory itself. You can finally break that von Neumann bottleneck for good. This is the very foundation of what we call neuromorphic computing, an architecture that could lead to AI that learns with mind-blowing efficiency.
He had this really powerful way of picturing how it worked. He visualized each little pulse of energy, creating these tiny crystalline islands inside the amorphous sea of the material. As you add more pulses, the islands get bigger, they start to connect, until finally they form a complete bridge, and the device switches on. It fires, just like a nerve cell. It's such a beautiful analogy for how information and energy can become the same thing.
Tragically, Ovchinsky was actually forced out of his own company in 2007, and this incredible research into cognitive computing, it was just shelved. But now, as we're hitting the physical limits of what silicon can do, and the energy demands of AI are getting totally unsustainable, his work is being rediscovered with a new sense of urgency. His former colleagues, major tech companies, they're reviving this very same technology, seeing it as a potential path toward a true artificial general intelligence that doesn't require the power of a small city to run.
So we're left with this really fascinating question. As we push for AGI, a machine that can truly think and learn like a human, could the answer lie not in building bigger and bigger supercomputers, but in the forgotten vision of a high school-educated machinist from Ohio, a man who saw the future in a flash on an oscilloscope screen more than half a century ago?